Okay, let's have a look at question 2 from the January 2009 D1 paper. And the first thing we have to do is use this table to draw a network. So let's have a look at the answer booklet that we're given. That's what we're given in the answer booklet, given the table there and some nodes. So let's see if we can do this. So we got that A connects to B, and the distance between them is 24. So let's put that on. A connects to B. I think I'll put the distances on after, just for the sake of using this this technology. But you could probably write 24 there yourself. C connects to B. That's a distance of 18. C connects to B. So we've done that. D connects to B, so let's connect them up. E connects to A, like so. E connects to B, 17. E connects to B. F connects to A, like that. F connects to B, like this, and D to C. D goes to C like that. E goes to C, like, whoops, like that, kind of. E goes to D, like that, and F goes to E. Okay, so we have this happening. You'll notice that this side of the table is a mirror image of that side, so we've done everything now. And as you were going along, you would have wanted to have put the weights on there as well, so I'll just do that. Okay, so I've now just put on the weights there. A to F was 22, as you can see. B to F is 20, and so on and so on. I just put them all on there. So there is the answer to the first part of the question. Let's have a look at the second part. Okay, in your answer booklet you're given a second diagram down here, and you're supposed to use Kruskal's algorithm to find a minimum spanning tree, and we're going to later in part C draw that tree on this second diagram. So for the sake of hopefully making things easier, I'm going to draw it on the first diagram, but you would obviously do it on the second one in your answer booklet in the actual exam. So let's have a look. How can we get this minimum spanning tree? First, what we need to do for Kruskal's algorithm is to list the arcs in ascending order of weight. So let's do that. Okay, so the smallest is 11. So that's DC 11. Now I'm going to include the arcs on my diagram as I go along, so I think that will make it easier. So DC, that's 11. Okay, next one looks like it's ED, and that is 13. ED, and remember with Kruskal's we keep going until we get a cycle. So far we have not got a cycle, we haven't got a loop, which is what a cycle is. So next one, 14 seems to be the next biggest. That's EC. Let's put that on. If we were to put that on, we would get a cycle. So what we'll do is we'll reject EC because it gives us a cycle, and carry on. So the next biggest one seems to be EB. So we'll put that on. And what was it? EB 17. Okay, next I forgot to write that. EB 17. Okay, then we got CB 18. Yep, that seems to be the next biggest one. C to B. That would give us a cycle. So CB we will reject because it gives us a cycle. Okay, and next we've got DB. So let's have a look. DB. Again that would create a cycle. So DB we will reject. And the algorithm states that we keep going until all the nodes are included. So we've got to keep going. So we'll now go for FB. FB. Yeah, that doesn't create a cycle. Whoops. Let's add that in. FB. And that has a weight of 20. And what have we got next? 22. FA. That doesn't create a cycle either. So FA 22. And let's just, oh look, all the nodes are included, so we can now stop. So let's write that down. Always important to include your stop condition, just to show that the reason why you've stopped, and the fact that you are going to stop. Now that's quite important, and they potentially could mark you down if you forget to do that. So let's just look back at the question. We've used Kruskal's algorithm, we've found a minimum spanning tree, we've listed the edges, we've drawn the tree, and finally we need to find the total weight. So let's just flick back here. So we're going to add up these numbers here, the ones that we've included. So we'll go for 11 plus 13 plus 17 plus 20 plus 22. It comes to 83. Oops. And you can just state that, and we're there. So that is how to complete question 2 from the January 2009 paper.